Welcome back once again. Hope you enjoyed the lab on using union. We're back now for module 5, which is about using functions and aggregating data. So we're going to start to do queries that don't involve just bringing back individual rows of data. We're going to start to group those rows up and create aggregates and count things and sum things and all those great sorts of things. So Jeff, what are we going to cover in this module then?
There's two broad things we're going to cover. Look at built-in functions, and there's broken down into scalar functions, aggregate functions, logical functions, window functions. And then we'll also look at queries where we can group up our data. So we'll look at a grouping clause where we say, let's just look at the totals for customer, for example, and having it connected with that as well, a way of filtering that information.
Sounds useful, okay.
So to look in a bit more detail, the built-in function side of things we're looking at, we'll go into these in more detail, but just briefly, we look at scalar functions, where they look at one row in, one row out, one value out. Logical functions, so we're just looking at using logic in there to return one single output. Aggregate, adding things up, and we'll do that a bit more later on with group by as well. Window is a set of rows, so we're looking at returning these, working with these sets of data. And row set, as it says there, return a virtual table, effectively something we can use as a table. In our Transact-SQL statement.
So those are the types of built-in functions that there are then? And
just broadly categorized,
okay.
Yeah.
All right, great.
So scalar functions, to start off with, it's a single value output. So if we do a scalar function, it's going to return a value.
Okay.
One single value. It's not going to return a table of information. It's not going to return loads of rows, loads of columns. It's a value.
Just something like the minimum or maximum or count or something like that.
Yeah, I mean, we look at aggregate as well.
Those are aggregates.
But the year of today's date, or what today's date is, for example, would be another one.
A single value.
A single value, and that gets returned. So today's date might be a valid one. We want to compare the due date with today's date. If it's greater than that, we've got a problem. So using a function to return today's date, we can do that.
So just to be clear, to make up for my earlier mistake, these aren't aggregates, so it's not something where we pass in a bunch of rows. I pass in a single value and I get back a single value.
Absolutely, yeah. One in, one out. So
okay.
So that's, and so if we're, rather than today's date, if we were looking at a year of a date, we're bringing one date in, returning what the year of that date is out.
Okay.
And if we run it on a set of data, you might say, well, there's lots of things going in there because there's loads and loads of rows. But the function's running on every single row independently of the other ones.
Right.
So it is seeing them as lots of different runs of the same thing, not one aggregated thing. There we go. I've said that already. Can be used like an expression in queries. So in the same way we had things which were concatenating text, and we had adding up numbers and these things, we were working with our data in the same way we can do that. So I said we could use the year of a date, or we can display that in our query. We can have year of get date, that gives the year of the date now, and then display that, use an alias, same, so we could say adds year of today or something, whatever you want, and that would display in the same way.
Okay.
Deterministic or non-deterministic, right.
Okay.
This is, if you get onto more of the design of databases, there are some things that will have rules about whether they can or can't be deterministic or non-deterministic. So we need to know what that means. Essentially, if I run a function on using certain data, I can either expect to get exactly the same value back every time, or there'll be scenarios where I don't get exactly the same value back every time, even though the data might not have changed. So I said an example would be, what if we had the comparison with get date and a due date? So would that always return the same value, do you think?
Well, no, because get date returns today's date, so it depends on which day you run it.
Absolutely, yeah.
Right.
And even more accurate than that, it's going to be the time as well. So we, almost always is going to be slightly different.
Right.
And so that's not deterministic. We can't say what the result will be based on the data going in.
Right.
Whereas if I was to concatenate two columns of text, assuming the data hasn't changed, we know what the result will be.
Right.
It won't change over time.
Okay, so that's
it will always be the
deterministic.
same.
I see.
There's just an example of some of the. There are categories there because there's a huge amount of functions in SQL Server.
I was going to say, yeah.
We're looking at a flavour of these. Looking in books online and the documentation, it has all the information about all the different functions. Once you've got an idea of running a few different functions, you'll get used to the concept of functions and what they look like. And with books online, you can really, if you think, oh, I'd like to be able to do this with that data, have a look.
I'm disappointed you haven't got a slide on every single function. Yeah.
I seem to remember that about 12, 15 years ago, we did once have that sort of slide. Now, it would be many, many slides. So we're going to have a look at scalar functions to start off with. So I've mentioned the year function. This will return the year of that value in there. So if I run this, then we can output the selling start year of all of those. So we can see when that product was starting to be sold and the year of that product starting to be sold. And that's using a simple function, just returning the year. Slightly more complex, expanding on that. We're now going to use year, but also I want some more information. So I want the month, and that's using date name. That would actually supply the name of the month rather than the number. That would be July
so like
or
March
June,
yeah, okay, I see.
Yeah, rather than just a number. We have a month function as well to return a number, so we can do either, whatever's preferred. And then the day as well we've got in there, so we can use day functions, month functions, and you see in there a date name as well. We've got the DW, so you've got different syntax we can use in here, for our month, and this is the weekday is a DW, so you've got different syntax to provide different bits of your data information.
So the date name function then, depending on the parameters I pass in, I'm going to get something different back.
Absolutely, yeah, and you'll see that now because they're the same values going in on the cell start month and the cell start weekday, but we can see one of them's returning June's, July's, the other one's returning
the actual date
Friday,
name of the week.
It's returning again the date name. We can return numbers or names for any of you. There's functions for both, so we can. You see that we've got a day one there as well. We've got cell start day, so we can return values based on what we want in the output in there.
Okay.
Right, another useful one. I mentioned already about what happens if we've got an order date and the current date. Well, here we're actually looking at the start date, but we might often want to compare two values. And if comparing dates, date diff's a very useful one because we don't just want it to compare as a number. Although actually you can convert dates into numbers. They are held as numbers actually. But here I want to make sure, I want to have a look at how many months, years, days are in between
what's the time
these
interval,
two values. Yeah. So we can be a bit more specific. And it has built-in date functions to allow you to deal with that specific type of data, which behaves differently to anything else. I mean, what else would have 365 of one unit and another unit, and that unit is also split up into 12, but that doesn't quite fit into that one. And
not to mention leap years and all that. Yeah.
So we have the specific functionality to deal with dates because of that complexity. So here we're looking at the difference in years between the start date and the current date, so we can see how long we've been selling these products for. We could see actually from the previous, so this one we're saying it's 13 years, 10 years, and we can see how
from
many
today's
years.
date on the day we're actually running this demo.
Absolutely, yeah. And that's when we're saying deterministic, non-deterministic, well, that will change. In a year's time, those numbers will be one higher. So.
Sure. I guess, I mean, it's probably worth interjecting at this point and saying date functions. There's a huge array of very, very useful date functions, and you can easily spend a long time playing with the documentation and looking at what they all do.
Absolutely, I mean, because if you didn't have date functions, it's really complicated.
Yes.
As we said, things don't fit neatly into years, months don't fit neatly into years, weeks don't fit neatly into years, so we have specific functions because of that. Very simple one here, dealing with a bit of text. So we would like to convert the name in here to uppercase. So ultimately just go to uppercase.
I mean, a good example of where I might want to do that, some people might think, was that just purely for the purposes of displaying it neatly in uppercase or whatever. But actually, we mentioned previously in this course, sometimes a database may have a collation where the data itself, the values, are case sensitive.
And we can make a database.
Yeah.
We can turn them case sensitive.
So it's quite common to have queries where you're comparing the value, where name equals, and to use an upper and then compare it to just in case. It's a mixture of case, because you won't get an equal equals true if it's a case sensitive database and the case isn't exactly the same. So upper and the equivalent lower are quite commonly used just to make sure we're all starting from a level playing field when we're comparing strings.
Mm-hmm. And you get some things which are always uppercase. I mean, in the UK, our zip codes, our postal codes are always uppercase. So it would look strange to see them in any other way, and you want to convert them. We have a slightly more elegant way of concatenating here. So we could do first name plus last name as full name, which we've done already. This one's using the concat function to get the same results. And we have exactly the same result as before, but just maybe looking a little bit more elegant using a function to do that.
And you could, you could nest that concat. We're using both techniques there, because you've got first name plus the space.
Yeah. You could concat.
Yeah, you could concat the concat and get it that way. Yeah,
I think that might lose the elegance.
It might, but yes.
And now we get on to some more interesting ones. Now the first one's very simple. So what we're going to do is we want to return the left 2 digits of the product number from the product table. And that's a very straightforward thing to do. And there we go, FR, HL. Those are the first 2 digits from that table.
First 2 characters, specifically we're talking about character data.
Digits, the characters. So that's simple. We have a right one as well, and we can say, okay, I want the left or the right. So in this situation, we've got product numbers. They're actually made up of a number of different components. We've got at the beginning, we've got product type, first 2 characters. The end, we've got the size, actually. That's the last 2 characters. They've got 58, medium, large. We've got bits of information which are actually stored in the product number. And that's quite typical, actually. And you might want to strip that out of there and say, actually, I'm interested in a particular part of that information. Now, it can get quite complicated to find that bit of information you're interested in. If it's the left 2 characters, it's not a problem at all. But what if it becomes a little bit more complex? What if we have to search for values within the string, and when we find the value, then we can start retrieving information? So here, we're going to start with just the first 2 digits of the product number, as we did before. But we're also going to search for some more information. Now, we're going to use car index to find dashes within there. We're then going to move across 1, so we're going to add 1 to that, and use substring to retrieve not the left or the right, but a portion of text from within that string. In this case, we want 4 digits from within here. So we're going to look for the dash, which is going to find the first dash. So in this example here, we've got FR dash, so we'll find that dash, then retrieve the next.
So the starting for the substring function, the starting point is wherever the first dash is, +1.
+1.
Right.
Yeah. So it looks for the dash, finds +1, and then returns 4 digits. So that would be R92B for this one. That's the model code. So that's our code. That's where it's hidden within that product number. Then we've got a even more complicated one. Now we're looking for the right-hand side. We're looking for the size code. Now, not all of them have a size in here. So I'm looking for the right-hand dash in most scenarios. So in the first one, the right-hand dash and anything to the right of that is the size. However, once we go down here, we find actually there is no size. The problem if I look for the right-hand dash is it's also the left-hand dash. There is only the one dash. So I'd end up finding the U509 information, which is not correct. So what we need to do is search for the right 3 characters.
So we know that if there is a dash on the right-hand side, it's going to be a maximum of 3 characters from the end.
Well, yeah, and I know that we have a 4-digit code in the middle, which is the product code. So I know that if it's more than 3 across, then it's not the dash I'm interested in. If it's less than that, then that's right. The one I'm after. So we're going to only look at the right. Now we're doing everything backwards, so you have to think about things in reverse. So we're going to reverse that. Rather than it being in the right order, we're going from right to left now. So that's why it's being reversed. So now we're looking for the car index of that dash again. Finding that, in this time we're going to add 2 to that and return 2. So essentially it's going to be looking at, because we're reversing everything, adding 2, that takes us across to there, and returning 2, that's our 58 from here. So we're going to look at, well actually no, sorry, it's looking at how the length as well. We're doing length of product number minus that value. So we found that
because it's been flipped around.
Because it's backwards. So we're actually saying, okay, which ones do we want? Well, we want the substring of the length of the whole thing minus how many are off there. And we're returning just 2 characters off there. Now what it should do is, in this situation, what we don't want is anything to be returned in here. So that's the key, is that I think when you do this, the first time you do it, you get it wrong, because you go, oh, yeah, I got a load of 58, so that was fine, but I also got a U5 come out of this, because you think, oh yes, of course we've got some with that size. So then you have to change your logic each time. And thinking from left or from right works as well. So sometimes you're going from the left, sometimes you're going from the right, and you've got to think about which way round you're thinking. And it's an iterative process. You run it, you think, okay, well that's what it found.
One tip from me as well is each of these, because we've got lots of nested functions, each one you could do a select statement that just selects that bit
of
whatever it is you're working on. So you can see what the right hand 2 characters look like. You can see what the reverse of the thing looks like. And sometimes just going through the process of independently running each of those sub functions helps you figure out, well, how do I put all of these together? If the thing reversed looks like that, then I'm looking for that character, so it's the right.
Yeah.
It takes a little while to work your way through all the permutations.
I don't think there's many people who could write those sort of string search queries straight off. No,
it takes a lot of
the logic in your head. So you can see on that right-hand code there, it's found. So that the scenario where we've got HLU509-R is returned the R, when it's HL-U509, which didn't have anything afterwards, because that one has no dash in those last 4 characters, we don't want to return it. So that one's not finding any values within there. So it's not finding any dashes within the last 3 characters, so we ignore that one. That doesn't have a size code. And that's absolutely correct. We now know what the product type is, we know what the model number is, we know what the size code is. So we've broken down our product number, which was a number which might have come in historically or from somewhere else, and we've actually stripped out individual parts of information about our products. And
I guess what's important from this as well is just the importance of having test data that's representative of the real data that you're likely to have, so that you can test these permutations. And I think the key thing about including the demo in this course is not that we expect you from this to now immediately be able to, hey, I could sit down and I could write this query, I've learned how to do that, but to kind of show you how complex these things can become when you nest one function within another function within another function, especially the string handling functions. It has to be said, can be quite complex to work out.
It's really valid what you said, is to start small, because I think when I've shown students these sort of things, they just think, oh, I could never create that. You go, but could you create right product number, comma 3?
Can you find me the last 3 characters?
Yeah.
Yeah. Now that you've found the last 3 characters, yeah.
Well, maybe even then turn that into a number, or a digits. You know what that is. Okay, just type it in then. Well, could we find the reverse of that typed in code? And then you replace that typed in code with the function that generates the typed in code, and you can build it up, and ultimately you think, oh wow, I have created this thing which is really complex. But breaking it down into small units and doing it that way.
Great.
So now we're going to have a look at logical functions. Now we're doing tests on our data in here, and it's comparative logic. So we're saying true equals true. We can test for things being the case. So the first one is numeric. So we want to know, is this a number? So 101.99, is it numeric? And basically that's just running it against something that's been typed in. But we can also run that obviously against columns in our database as well. So we can test for things being numeric in here. We've got this. This is you get in some applications as an if in here, but an if is done as a function, which is in row or immediate if. in here. And what it's doing, it's saying, okay, let's have a look at a test. So we've got list price greater than 50. If it is, display high. If it isn't, display low. So we've got a test. What to do if it's true? What to do if it's false? So if the list price is greater than 50, display high. If the list price is not greater than 50, including it being equal to 50, then display low. So we can output information using a logical test. And then we've got choose in here. So this one, we've got multiple different category IDs within here. So the product category ID, if it's a 1, display bikes. If it's 2, display components. 3, clothing. 4, accessories. So we can turn a code into words which are more meaningful. And it does that without using another table that's being used to convert those values over. We can just do it in the function.
But it's the ordinal position. I mean, it's always going to start from 1, 2, 3. It's the ordinal position within that list.
Yeah.
Which begs the question, what happens if the product category ID is 5 in this instance? Because I've only got 4 options, which will be 1, 2, 3, and 4.
Then we're going to get a null value if it's anything higher than that. This is not a solution to say, well, I don't need to create a categories table anymore. There are many advantages to having it as a table, because what if one of those rows changed or anything happened? We can deal with it much more easily with a table. But it is a nice way of saying, okay, well, I just want to now do this. We always use it as codes, but actually someone's asked me to output these values instead of codes. We can do that. We can do a conversion. So it's rather than starting to say, well, couldn't you do that with the if and then nest lots of ifs inside each other?
Which you could.
You could.
But I mean, I guess where I have seen it used is if you have something that's perhaps performed in a series of phases. So the status of an order might be 1, it's been placed, 2, it's been paid for, 3, it's been delivered. And we know that it's always that sequence of steps, 1, 2, and 3.
Yep.
Then it becomes very easy to assign some sort of label to what those things are.
And we'd never have any other values. We'd never worry about the nulls. Then it would work fine. And doing that nested if would be really complicated when you start looking at it and you have nesting within nesting within nesting, and you think about the logic with complex.
And earlier on in the course we saw a case statement, which is another way of doing this type of thing. It's not a function per se, but it's another way of comparing values and giving a result back out. So you've sometimes multiple ways of doing the same thing, and the best one is going to depend specifically on the data you're working with, I guess.
Absolutely. So looking at some examples of logical functions, we're now going to have a filter through the product table. Now, the product table has a mixture of different sizes within it. So we've got 58 in here. We've also got M for medium, L for large in here. So what we're going to do is use the isNumeric function in here, because I don't want to get an error all the time. I just want to find the numeric sizes. I'm not interested in small, medium, large. I'm interested in all these sizes of bikes in here. So I only want to find these numeric ones. So isNumeric we're using in there to find things that are numeric within, although obviously stored within probably a varchar, I imagine, within there. So, but it is numeric data. So it's finding numeric data within a text string data field.
So in this context, the 1 doesn't mean the number 1, it actually means true.
True.
Right.
Yeah. So we can find true, false within there. So we could search for a 1 or a 0. Now the next one, we're going to say if we have a product category of 5, 6, or 7, it's a bike. And if it's not, it's something else. So all we want to do is display bike or other from there. So we've got an if product category ID. So that's what we're looking at and testing it to say, is it in this list of numbers, 5, 6, or 7? True is bike, false is other. So then we're just going to get a lot of products and whether they're in bike or not. And there'll be some in bike as well down here.
There you go. Yeah.
So now, combining the two, we can use isNumeric, which we've already seen. If isNumeric size is 1, then it returns a true. It is 1, so that would display numeric. If it's not, it would display non-numeric. So we can display whether our sizes are numeric or not So just expanding and combining the two previous ones. So we've got an if and we've got an is numeric. Combining the two, we can have a look and see what size type we've got within there. And then using choose, so we've got bikes, components, clothing, accessories as our first four product categories. So we're going to choose the category ID, display bikes, components, clothing or accessories as a product type from there. We've got a join on here as well because the data is coming from two tables. And you can see now we've got bikes, we've got components, clothing, accessories within there.
And that's because we knew ahead of time that those categories were numbered 1, 2, 3, and 4.
Yeah, so that's where you long term, if you're using this repeatedly and those things might change around, then you're thinking, well, maybe we need another table at some point to speak to the database designers. So could we have something actually listing that information, and we'll do a join, because then it will always check the correct value.
Right.
Okay. That's all of those ones. So now we're going to have a look at window functions. So these are applied to a set of rows, set of data. So the window it refers to is a set of rows.
Nothing to do with the windows, the product. This is purely a window of rows.
It's not even anything to do with the thing you look out of, made of glass.
Right, okay, good.
That other arcane use of the word window.
Yeah, that's right, yes.
So here we're looking at ranking our data. So I would like to have a ranking by price. I want to know what the most expensive product is, second, third, ranked product. So we're going to use a rank, and it's over and then a set of data. So they're order by list price descending. I want to get all of the list prices descending, and then I want to see a ranking of those, 1, 2, 3, as it goes through.
So the rank function then, rank over, is returning the ordinal number that indicates whereabouts in the hierarchy of values this thing falls.
And if you get draws, you'll have it in the same way you get draws in sort of sport or whatever. You get sort of 1, 1, and then the next one, if you get to a draw at the top and there's a 1 and a 1, the next one's not a 2, the next one's 3.
3, because it's the third one. Right?
Third down, yeah. So you'll get that. Draws get the same number, but then the next number is how far down you are.
Right.
Right, I'm going to move down now to have a look at some of those window functions. So to start off with, the top 100 products, we've got an order by in here, rank by price. Now rank by price is actually going to be set up here. So there's two things going in. We've got the rank and then over, and it's over the order by list price descending. So I'm not ranking it by what we ultimately rank the query by. So we ultimately rank the query, or order the query rather, by rank by price. So I'm going to say, no, in list price order descending, I would like to have that rank by price value. So the rank in there will give me a number based on their list price. So over that whole window of 100 records. Now you'll see if we get equal to, they're all ranked 1. So the first 5 in here have all got the same number, they're all ranked 1. And then the next one is a 6 because you've already got 5 ones preceding it.
So it's worth, I guess the way to think about this is $3,578 is the price of those first 5 rows that we've got there. So what we're not saying is that Road 150 Red 62 is the most expensive product we have. We're saying that the price of Road 160 Red 62 is the highest price that we have.
The highest list price that we have.
Yes.
Yeah.
So you're actually ranking the prices.
Yes. And it's just giving us a number. It's not, we could have one thing in there which is 1,000 times more expensive than the other. It'd still be ranking 1, the next one will be ranking 2.
2, yeah.
So it's not, and the number's just jumping up from 1 to 6 because we have 5.
They're
the same product, it's just they're different sizes.
Yes.
So yeah, again, you could argue maybe that in the future maybe we'd actually strip those out and have a products table that actually just had that as a product, and somewhere separately had the details.
Had the details of the colour and so on, yeah.
Yeah, but you can see what it's doing there. So it's a way of ranking data, because the problem with working with sets in SQL is that it's not something that runs down from row 1 to row 2 to row 3 to row 4. We don't have numberings in that way. We don't have row numbers or anything like that. It's a way of saying, well, I'd like to have a number which goes down from the top to the bottom, telling me what number they are in there. And because of the way it works, and the data's not ordered until we do an order by, we need to add that in afterwards.
Okay.
So now a little bit more than that, we're going to do, rather than the simple rank over order by list price, we're going to say, add in a partition by, and here c.name, C refers to the product category. So essentially we're going to say, if you like, group by product category. So for each product category, give me the ranking. So adding an extra level within that, using this partition by in here. So now, what we'll see is that the first three, that's fine. They're all number one. They're 89, 99. You think, well, that makes sense. But the next one we've got is 120. You think, well, why isn't that above those ones? Well, it's a different product category. The first three being one, those are all the number one bib shorts. The next one is the number one bike rack. The next one is the number one bike stand. And then we'll go on to the number one bottle and cage, number two bottle and cage, number three bottle and cage. So we're going through each of the product categories and ranking them.
And the point is, the reason that we've got a number, well, okay, to break this down, the reason that all of the bib shorts are number one is because they're the same price. Yeah. And there are no other types of bib shorts, so all of the bib shorts are the same price, so they're all equal first.
Yes.
The reason we've only got one bike rack is because we only actually sell one bike rack.
We have an order by category, so yeah, it is. We only have one bike rack.
We only have one bike rack, and in that
three.
category, there's only one product, so obviously it's the most expensive one.
Yeah.
Where it gets more interesting, and the same with bike stands actually, but where we get to bottles and cages, we have multiple bottles and cages that are different prices, and that's where we start to see the first, the second, the third. Yeah.
And we'll talk about group by later on, but group by something that wouldn't do this, because it's not going to look at where you sit in the queue. Right. It's going to add up. It will give me a sum, or it will give me an average, or it will give me a count, but it won't say, well, where's each of those individuals in the list. So now we'll have a look at aggregate functions, and we're going to look at, rather than ranking something or doing a scalar function on something, we're going to look at doing sums, counts, max, min, average. Again, there's lots of different aggregate functions. We're covering some of the key ones. But if you want to do standard deviation, you could do that. Mm-hmm. And Graham's obviously, you're going to describe to me the difference between standard deviation and standard deviation of a population? No, he's not, don't worry. I remember this.
Come back for another course sometime, yeah.
Yeah, there's really complicated things which I can vaguely remember from many years ago at university doing statistical modelling. I can't remember what they are, but there's a huge number of different statistical functions we can do within there. So again, once you're happy with something quite straightforward like a max or a sum, you can see that you can get out things like standard deviation values as well. Mm-hmm. In fact, it's really straightforward. I can produce the information, I just can't tell you what it actually means. So stdev is the function. So we're looking at functions operating on a larger quantity of data. Again, not just one row, we're looking at aggregating data. So we're looking at sums, we're looking at max, min of a set of rows of data. And we're going to summarize that information however we define. And we've also got a choice of group by, which we'll come back to. But without the group by, we get the grand total. So if I do a select count star and a sum of order quantity times unit price, those are grand totals for absolutely every record I have within there. So we can produce that total for the company and for all time, for all products, for all of everything. That's our grand total.
So this is back to correct my mistake from earlier on where I talked about scalar functions. A scalar function, it gets, if I have multiple rows and I'm using a scalar function in the select clause, it gets executed for each row individually.
Yes.
Whereas here what I'm saying is, look, take all of the rows and then return me one value that is an aggregate of all of those rows.
Absolutely.
The count or the sum or the max or the min. Or
yeah, there could be a million rows here, we don't know. But sure. It's just grand total for this one.
Okay.
So to use some of these aggregate functions, here we're going to do a number of different things. We've got count star, that would just give us a simple count of products. We've also got in here a count of the distinct category ID. So the product category ID is how many distinct ones, how many different ones have we got within categories. And we've got an average in here as well, average list price. And there are as I said, there's loads of different ones. We could do a max, we could do a min, we could do standard deviation, we could do loads of things, just replacing that value. So they're used in the same way, so we won't go through all of them, but it's really simple. If you want to find the lowest one, just put in min, highest one max, for example.
Okay.
So in there, that's the grand totals of these things. So we can also filter this. Now what we're doing here is a count of product ID, then display the average list price, but only do that where the category name has the word bikes at the end in here. So it's filtering for that data. Okay, that's my grand totals. Again, we're not doing any subtotaling, it's grand totals, but grand totals for things which end with the word bikes at the end of their category name.
I guess one thing to pull out here, we're counting the product ID, which we know is a unique value. So we know we're counting the distinct bikes in this case.
Yeah, the primary key is the one to...
typically the one that you would count. You can use count star to count the rows, but of course that will include any duplicates that you have in there. So if you had a table, or if the results of the query included rows that were duplicates of one another, they'd be double counted.
Or if you've got nulls as well, if you pick a column and it's got null values in there, it doesn't count them.
Right. So count star can be useful. If you know that you want to just count the number of rows, then that's sensible. If you want to count a specific business entity instance, like products, it's quite often better to explicitly count what you know is the unique key for that product.
Yes. And we know we've got a join in here, so we could potentially get, once we start doing left joins and right joins, we're thinking, okay, what is it that I want to count? Because we may well get nulls creeping in there. And the way nulls are treated in aggregates as well is changes as our perception of how nulls work as well. You need to sort of check that, because if we've got nulls within our record set, they are normally ignored rather than being... So
it doesn't return an error, it just ignores them, and the count that we get back or whatever might not actually be right.
Because our max list price, you say, well, how can you say what the max list price is? Because you've got a null in there, that could be a higher value. But aggregates don't treat, they ignore nulls. So that's a consideration in everything we've said about nulls, or you can't ignore them because they're an unknown value. It could be millions of pounds worth of sales you're not counting because it's unknown, but slightly different with aggregates. We're going to go on now to look at group by. Typically, if we're doing aggregates, you're most likely to use group by, because at the moment we've only looked at grand totals, and that's all we can display without using group by. Actually, what we want to do is add a bit of context to this, so a total for a category, for example. So we're going to add group by, and we're going to say group up, and you have to group up everything that's in the select row that's not being aggregated. So you can't have something in there that's not grouped by and not aggregated. It has to be one or the other when we start to add it. And what we're going to do, we're going to have a look at summarizing for each of those things that we're grouping. So if we group by product ID, we want for each product, give me the total. For each product, give me the count. And the detail rows are lost, so we don't see what goes into it. We don't see those individual values anymore. We'll see a much reduced record set, so we might have 5 rows returned from 1,000 rows in the detail. We don't see the individual detail within there. So this one's saying group up by customer ID and show me a count star. So how many rows are there in sales order header for each customer? Right, just switch over here. Let's have a look then at grouping up now. So if we have to group by. So if I were to start without my group by, then I get an error. So we've got a column in there that's not contained in either an aggregate function or a group by clause. You can't have things that are in neither of those two. If I were to say the first salesperson or do an aggregate on it, then it would work. But as it stands, it's not either. So we have to do a group by, or we have to do an aggregate on it. So let's add that. Now for each salesperson, we're looking at the sales revenue. Okay, so we're doing an is null on there as well. So it's going to sum the total in there and basically display the grand total of each of those sorry, not the grand total, the subtotal for each of those for each salesperson.
And of course, because we've used the left join, we've included salespeople who haven't sold anything.
Haven't sold anything, and we're getting zero.
Hence the is null.
So now what we're going to do, again, adding in. Now, you need to be careful if you said in here. Well, we've got basically the same thing, but we've added in this concatenated function in here to display the customer. And this tends to be, if I get it wrong, is when I add another column and then you forget to add it. You add it in the select list, you forget to add it into the group by. So you see it's been added here, but exactly the same thing's been added here. Now you might say, well, actually that's a function. And it is a function, but it's not an aggregate function.
Right.
So it's not just that you're in a function, and that's again maybe more confusing because you think, okay, let's have a look across here. There's only one thing that's not in a function, that's salesperson. Well, that's in my group by. But this is in a function, wrong sort of function. So it has to be in an aggregate function.
So I mean, the other thing is, though, we've got concat first name, last name, and so on, but we've given it an alias. So can't I use the alias?
So we're back to the order that things are run in as well. So we've got the select in here as customer, but the select, remember, runs right near the end.
So group by happens before select.
But the only thing running after, order by, and there we've used the alias.
Use it.
So yeah, it's, again, I think it's one of those things to keep in the back of your mind all the time because you're going to make that mistake sometimes. I think everyone makes that mistake sometimes. And you think, oh, of course, yeah, it looks right because I've declared it on the first line. Actually, it's not running it from the first line onwards. In fact, I mean, it runs it as one line.
Right,
that's the key to it.
One thing,
it's just one thing. So now we've got, for each salesperson, we've got their name, we've got the sales revenue. So although we've used a function on that, just remember it's not any function, it's aggregate functions only.
So we're getting groups within groups here. We're grouping first of all by salesperson, and then for each salesperson we're grouping by customer, and then we're seeing the sales revenue for each customer.
Yeah, because that's c.first name and c.last name, so that's coming from the customer table.
Yeah.
Within there, so yeah, so for each salesperson, we've got.
The salesperson's also coming from the customer table because each customer has a salesperson assigned to them.
Yes, but so each salesperson has been grouped up, and then within that we've grouped up each customer. And so the order actually of group by is relevant as well. We're grouping by salesperson first, then by the customer.
So if we're building sort of cascading totals of things, then you're going to group by each level that you want to summarize, I guess.
Yes, so that becomes important which order you do the group by.
Okay.
Within there. Right, so we want to filter. We've done a filter. We had a filter with a where in here. We can do that. We can put a where into our aggregate functions. That works, and it is valid. But most of the time that we filter using an aggregate, we filter using having. What having does is it will filter the results rather than the input. So we've got a search condition that each group must satisfy. So we've grouped up. And then each of those groupings, we've got an aggregate and we want to check that those aggregates reach a certain value. And typically you're going to display that value. You actually don't have to display that value, but it is very unlikely that you wouldn't. But you could actually say, no, I want a list of customers that have more than 10 orders. I don't want to see how many they've got, I don't care. I just want to know what those customer IDs are. So you don't actually have to display the value you've got having in. Most of the time you will, and almost certainly when you're testing it, you would, just to make sure it's correct. So
I guess, the point there, the where clause comes first. And I think one way that's important to think about this is you use the where clause to eliminate rows that you don't want to include in the groups. And then once you've done that, you use the having clause to eliminate groups that you don't want in the results. So there's sort of two phases of elimination going on here.
The where is happening before the aggregation, the having is happening after the aggregation on the results of the aggregation.
Yeah.
What we're doing here, to start off with, is a where. So it's working on the input. Before we get to aggregation in here, we're looking at order date of 2008. So we can run this, and it's perfectly valid to filter using a where, because we're not filtering on the results, we're filtering on the inputs. Well, let's have a look what happens. I want to have a look.
So hold on, before we do that, let's explain what the query does. What we're getting from here is, for each product ID, we're getting the order quantity and we're filtering that for orders that were placed in 2008. So for each order into each product that was ordered in 2008, tell me how many were actually ordered.
Yeah, absolutely.
Okay.
But I want to also filter and say, no, actually, I only want the ones we ordered lots of, so I only want ones with a quantity higher than 50.
Okay.
So the first thing we might do in there is say, well, we've already got a where in here, so we could say, well, how about we add an and to that and say that the sum of order quantity is greater than 50, which looks fine. It reads okay if you read it out, but you can't have that. An aggregate may not appear in a where clause. In fact, if you carry on, it kind of explains how to fix it. So it goes on, it says about havings in here. It's quite a long error in there. And that's what we need. The key thing is that word having in there. So if we remove it from here, we're going to leave the 2008 in. I still want to filter that. I only want to find ones from 2008. But I want to add to this to say that it's having a sum of order quantity greater than 50. So after we've done the aggregation, now do the test. You can't do it on the where because the where ran before we aggregated, so it doesn't know what the sum of order quantity is. So it's all down to that order of execution again, which is an important part. And now you'll see they're all over 50. It's filtered. They're all 2008. They're all over 50. 2008 has to be done on the input because it's not aggregated value. 50 has to be done on the output.
So the where clause filters my sales to only include the ones that were in 2008. That's individual rows that I'm filtering out. It's then going to group those rows by product ID, and then it's going to filter out the ones where the grouped row don't have an order quantity greater than 50. So it's key to kind of get your head around the idea that where filters out rows that may then be grouped, and once you've grouped them, you can then filter out groups using having. Yeah.
And if you ever do get it wrong, that error message that it displays mentions the word having in the error, so that straight away light bulb, and you think, well, of course, it needs to be in a having. So we've had a look at a number of different things. Two sort of core differences. One is general functions, which could be scalar, dealing with individual values in and out. Aggregate functions, where we're adding up, averaging, max min, working on a set of data. Logical functions, if it's this, do this. If it's something else, do something else. Window functions, working with a set of data. And then those aggregate ones as another sort of subject, aggregating data. We're going to aggregate them and then group up so we can have subtotals and then filter the results using having. Great.
So we're really getting to the point now where we're starting to build much more complex queries than when we first started. We're starting to see how to aggregate our data and use those functions to get lots of additional values over and above what's already in the tables. There is, again, a lab that goes with this module, so we suggest, once again, that you download the lab documents and files for these labs. You use the Getting Started guide to get your environment set up and get ready to go, and then do the lab that goes with this module on using functions and aggregating data so that you're comfortable and you get a chance to try this out for yourself. And then when you're comfortable with that, you're ready to come back, and we'll go on to the next module, where, well, it gets exciting in the next module. And this module we had functions within functions. In the next module, come back and join us to see queries within queries.